section 4.3, which if you notice says trigonometric functions on the unit circle. And so real quick, we just kind of got an excerpt, a kind of intro. You don't need to write this down, but we're just going to read through and talk a little bit about it because it does pertain to what we're doing. It says a blood pressure of 120/80 measured in millimeters of mercury means that a person's blood pressure oscillates or cycles between 20 millimeters above and below a pressure of 100 millimeters of mercury for a given time in t in seconds. A complete cycle of this oscillation takes about 1 second. So understand, if you have 100 millimeters of mercury, okay, 20 above would be 120, 20 below would be 80. That's where the 120/80 comes into play. Okay. If the pressure exerted by the blood at time t equals 0.25 seconds is 120 millimeters of mercury, then at time t equals 1.25 seconds, the pressure is also 120 millimeters of mercury. So it oscillates. When something oscillates, that means it fluctuates from one to the other. And so we're going to be getting into things that oscillate, specifically the trig functions. And so real quick, I don't know if you necessarily need to write these down because we're going to draw the triangles and we're going to already utilize our information that we've learned before. It says let theta be any angle in standard position. So standard position, we always start at the positive x-axis. Okay, and point PXY be a point on the terminal side of theta. Let R represent the non-zero distance from P to the origin. What is another name for R? Radius, thank you. Okay, that is let R equal square root of x squared plus y squared equals 0. So let's imagine we've got our triangle here, right? And I know that this is side x and this is side y. How could I find R? Right, that's all this is. This is nothing more than the Pythagorean theorem. Okay, and so like I said, this is something that I don't know if you necessarily need to write down because we've already learned a lot of this. The trig functions are as follows. So they're telling you that you get y over r. Well, let's look at this triangle. Here's my angle, right? We know that sine is what over what? Opposite over hypotenuse. Well, let's see. The opposite side is y. The hypotenuse is r. We already have it. What is cosine? Adjacent over hypotenuse. So what's the adjacent side to this angle right here? X over r. So see, this is already stuff we've done. So let's go ahead and look at an example. It says let 8, -6 be a point on the terminal side of an angle in standard position. Find the exact values of the 6 trigonometric functions of theta. So, very first, so if you're doing this, I would just put 8, 6, and then I would put find exact values of 6 trig functions. Okay, if you're doing this in your notes, you don't need to write everything down.
Find 6 trig functions.
Yep. So the very first thing you need to do is plot the point. So let's see, I'm going 8, and then I'm going down 6. So here's my point. Okay, now if I'm going to draw that angle in standard position, I'm going to go ahead and draw a radius out. Now this next thing is I need to make a triangle. So in order to make a triangle, you need to remember one thing. You will always draw from this point to the x-axis. You will always draw from whatever point you have to the x-axis. So obviously I'm going to have a vertical line here. You will never draw to the y, ever. So you never make a horizontal line. You always make a vertical line. Okay? So what I've created is I've created a right triangle here. What is my horizontal side, the length of it going to be? The horizontal side? 8. What's the vertical side? 6. So now I need to find the hypotenuse in order to solve. Okay? In order to find the hypotenuse, I'm going to do 8 squared plus equals x squared, c squared, r squared, whatever. 8 squared we know is 64. 6 squared we know is 36. What is 64 and 36? 100. Now in order to solve that, I need to take the square root. Square root of 100 is 10. And this is actually one of those triangles that hopefully you can file away to memory, 6, 8, 10. So now I need to find sine, cosine, tan, cosecant, secant, cotangent. Okay, and so now the question is, which angle am I using? You're always using the angle that touches the x-axis. Okay, so in this case, this angle right here. Now understand the right angle touches the x-axis, but we never use that for a reference angle. Okay. So now in this triangle, let's go ahead and label sides. If this is my angle, what side is 8? Adjacent. What side is 6? What side is 10? Hypotenuse. So using that, what is sine? 6 over 10, but you know I won't accept that. What will I accept? 3 over 5. So then therefore, what's cosecant? 5/3. Okay? Cosine. Oh, I forgot one thing. What did I forget? What did I forget on sine? Look at where the point is located. Yep. Forgot to have a negative here. That was my mistake. Good thing we caught that. Okay, so this should actually be a negative, and a negative. So make sure you don't lose those negatives, like I did.
So does that change your?
It's just negative.
No, it's just a negative, yeah. It doesn't change anything. No, it doesn't even change your square, because if you square a negative, remember, it just makes it a positive. Okay? All right, cosine, what's cosine going to be? 8 over 10, which reduces down to 4 over 5. Okay, so that means secant is 5 over 4, very good. And then tangent. Tangent? Try again. Negative 6 over 8. Yep. So that would really be negative 3/4. So cotangent is negative 4/3. Okay, so there you go. Those are your 6 answers. So all you're going to be doing is plotting points and finding the 6 trig functions. Now we've got one additional slide that we're going to look at today, and this is going to lead us into what we're starting tomorrow. And we're going to talk about quadrantal angles. Okay, so quadrantal is a big fancy word. Okay. So 4, you're right, because quad is the prefix. And so what we're doing is we're talking about the quadrants. Okay? So quad, you know, is 4. And when we talk about a coordinate plane, we have 4 different quadrants. And so that's the angles at each of the quadrant boundaries. So there are 4 of them. We start at 0. Then we go to 90. Then we go to 180. Then we go to 270. And we call those the quadrantal angles. What I want you to get down here with each of the quadrantal angles is notice at each of the points. Oops, let's get out of there. This is r comma 0. So whatever the radius is, okay, if it was 1 comma 0, 5 comma 0, that would be the point. At 90 degrees, my point is 0 comma r. And so those are just points that we locate like on the y-axis, x-axis. That shouldn't be anything new. Over here, the point is located at negative r, 0. And down here, it's located at 0, negative r. Now one of the other things I hope you get down is that 0 degrees and 0 radians are equivalent. 90 degrees and pi halves are equivalent. 180 and pi is equivalent, and 270 and 3 pi over 2 are equivalent. Okay, you need to file those away to memory. 0 and 0, 90 and pi over 2, 180 and pi, 270 and 3 pi over 2. Each 90 degrees is what fraction of pi? A half, right? So pretty much you go 0, 1/2, 1, 1 1/2. Okay, that's what 3 pi over 2 is. It's 1 1/2 pi. Now your assignment for tomorrow, yes it's due, even though we're continuing this section, we are going to check this specifically. Okay, we're going to split this section up. It's going to be found on page 251. Okay, on page 251, I want you to do 1 through 8 all. Okay, page 251, I want you to do 1 through 8 all. And so that is going to be your assignment. Remember, it is due tomorrow.